Radhe Radhe. So today we are going to cover the first topic from graph, that is topological sort. Topological sort अपन लोग फाइंड करते हैं वर्टेक्सेस को इंडिंग टाइम के ऑर्डर में सॉर्ट करने के लिए. दैट मीन्स कि हमें जब भी वर्टेक्सेस चाहिए उनके इंड टाइम के बेसिस पे, तब हम टॉपोलॉजिकल सॉर्ट का यूज़ करते हैं. But there is a generic say, like we cannot have a topological sort of a graph which is not DAG. A DAG is a directed acyclic graph, and we cannot have a topological sort for graph which is not DAG. We'll see that with an example. Let's say मैं एक ग्राफ लेता हूँ. This graph is a directed graph. बेसिकली अगर हम इस ग्राफ पे एक ट्रैवर्सल करते हैं डेप्थ फॉर सर्च का, फेस ट्रैवर्सल करते हैं, तो इस ग्राफ को विजिट करेंगे हम एज सच. लाइक इफ विल स्टार्ट विद द वर्टेक्स 5, it will go from vertex 5 to 2 to 3, and then it will go to 1, and then we'll visit the vertex 0, and then the vertex 4 will be visited. This is not the topological sort. ऐसा इसलिए है because if you'll see, the ending time of 5 is at the last of 0, 2, 3 and 1, which this particular thing is approaching, like 0, 3, 1 and 0 are ending before 5. That's why it is coming after 5 in this particular thing. But if you look at 4 is ending before 0 and 1, but in this particular DFS traversal we can see 4 is not ending before 0 and 1. That's why this is not the topological, that's why we cannot consider DFS as the topological sort. What should we do to get the topological sort? जैसा कि हमने पहले ही डिस्कस किया था कि टोपोलॉजिकल सॉर्ट हम डैग का निकालते हैं, एंड डैग हैज़ अ प्रॉपर्टी, देयर मस्ट बी अ वर्टेक्स which has in degree as 0, and there must be a single vertex at least which has a out degree as 0. That is the basic property of graph. Why so? Because DAG means graph is starting at some place, and after visiting a lot of nodes, let's say graph is ending at some node. That's why we can conclude like a graph is having a node which has in degree 0, and graph has having some nodes which are having out degree as 0. So we can use this particular approach to find the in order traversal of this particular graph, and basically find the in degree of each graph. Let's say I'll just copy paste this particular graph here, and then I'll find the in degree of each nodes. Let's say we have a node from 0, 1, 2, 3 and 4, 5, 3 and 4, 5. So basically 5 is having 0 in degree. As you can see, no edge is been falling on 5. That's why 5 is having in degree 0. 4 is also having an in degree 0. If you look, 0 is having in degree of 2, 1 is having an in degree of 2, 2 is having an in degree of 1 and out degree of 1. So simply we are just finding the in degree, that's why we'll look for the in degree only. But 3 is also having an in degree of 1 only. So as we have found the in degree, we'll do a BFS traversal with the help of this in degree array will create a queue, insert all the nodes that are having in degree as of now at 0. Let's say 5 or 4 is having an in degree of 0, so this particular queue will have the in degree. This is a queue. Will take out 5 and will print this particular 5. So basically we can directly print the queue dot front, and then after this particular, let's say I'll also start do the printing here. So 5 is printed. After that we'll look for the neighbors of the 5. 5 is having two neighbors as 2 and 0, so we'll simply put insert 2 and 0 inside the queue in any order. So let's say 2 and 3 are 2 and 0 are inserted. After this we'll pick 4 and pop it out. 4 is printed. We'll look for the neighbors of 4. 4 is having a neighbor as 1 and 0. 0 is already being already inside the queue. Will not insert 0 again. We'll insert 1 here, and now we have the next as 2. We'll pick the 2 out of the queue and we'll look for the neighbor. Neighbor is 3, and if we look for the neighbor, look for the next element. 0 is the next element. We'll pick the 0 out. So basically we'll keep the 0. 0 is having no neighbors from on which there is a edge from 0 to that particular neighbor, so we'll not insert anything inside the queue. So the next element is 0 1. 1 will take it out and print on the screen. After that we'll look if there is any edge from 1 to any node. No, so we'll leave it. We'll go to 3 and we'll print 3. So 3 is having an edge from itself to another node, that is 1, but 1 is already being printed and visited. In this way we are able to find this particular topological sort with the help of breadth first search traversal. If you want to have the pseudocode of this particular thing, we can write that also. So the pseudocode will start with like it will create a queue of integer type. The pseudocode will more often align with C plus programming only. So we'll push the first element. We'll push all the elements which are having the in degree as 0. For the first step is that one. So for int I is equals to 0, I less than and I plus plus. If in degree of the node is 0, we'll simply insert it inside the queue. After that we'll run a while loop. We'll check if queue is not empty. If that is the scene, we'll pick the front of the queue and delete that particular element from the queue. After that we'll simply first step is like we'll print the current element. I'll just simply write the current here. So we'll print the value of the current node, and now the next step will be like we'll check for any edge from the current. If int neighbor of current, let's say we have an adjacency matrix, so we'll check for the neighbor. If neighbor is not visited, visited of neighbor is false, we'll simply insert that neighbor inside the queue. So we'll push the neighbor to the queue. In this way we can end the while loop, and we'll have a topological sort printed on our screen.
A directed acyclic graph can have a multiple topological sort. In the next video, we'll look into finding the all topological sort of a single directed acyclic graph. I think that's enough for today. You guys can code this particular problem in your IDE. We'll meet again in the next video. Bye bye.